So here is the real eval1. So a self-evaluating expression, a constant. The value is the expression itself. If the expression is a symbol, don't be confused here. We're not calling eval1 on that symbol. That would be an infinite loop. We're calling STK as eval. So when we get down to sort of the base case of an evaluation, which is something atomic that isn't self-evaluating, we say, OK, STK, what's the value of this? And that value will typically be a primitive procedure. That's the only thing we really use globals for. Quote is a special form. This is what happens, remember, when you type a quotation mark, an apostrophe, into the scheme interpreter, the read procedure that we called up here turns that apostrophe into open paren, quote, blah, 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 close paren. OK? So that is a special form quote. And we're returning here catter of x. Why catter? Because I typed in quote foo like this. The read procedure turned this into quote foo like this. And the value of this expression should be foo, which is the second element of a list. If we look at this quote expression as data, its car is the word quote, its catter is the word foo. So that's what we want. We return this catter. Catter means second element. What if it's an if expression? OK. Now I have to convince you that this is not cheating. Namely, we're calling STK's if to evaluate the pieces of this. And we're taking advantage of the way STK's if works, which, let me remind you, it's a special form too. It evaluates the first argument, which is this. It's not catter of x, but it's eval1 of catter of x. So we evaluate the first argument to the if. We get true or false. If we get true, then we're going to eval1 the second argument. If not, we're going to eval1 the third argument. Now, why isn't this cheating? Imagine that for homework, you have to write an interpreter for Java in Scheme. OK? That would be a little much for homework. Maybe a project. Well, Java has a notation that looks like this. No, it doesn't. If x is equal to 0, do some stuff, else, these are braces, do some other stuff, semicolon. OK? So that's what if looks like in Java. How is your Java interpreter going to evaluate that? Well, the first thing it's going to do is some sort of parsing work, some grammatical work to extract the interesting pieces of that. The interesting pieces are this stuff in parentheses, which is the expression whose value should be true or false. So you grab that. And you grab this stuff, which is what to do if it's true. And you grab this stuff, which is what to do if it's false. The word else is not interesting. These braces are not interesting. This semicolon is not interesting. So we grab these things out of this syntax. And then what do? You're writing a Java interpreter in Scheme. Well, you have an if, right? You say if Java eval of that first thing, then Java eval the second thing, otherwise Java eval the third thing. And you wouldn't feel like you're cheating, right? You'd feel perfectly okay about using a scheme if as the implementation technique for a Java if. Well, we're doing the same job, except we're writing a scheme interpreter in Scheme. It's not cheating to use STK's conditional mechanism as a way of implementing our conditional mechanism. Just to make that point clearer, we could, if we wanted to, change the syntax of scheme if. Okay? So I'm going to write schemulator, a new language, schemulator. And in the schemulator language, you say, if blah, 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 then blah, 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 else blah, blah, blah. All these things in parentheses. Okay? So now along comes an if expression. We see the first word is if. Okay, it's the if special form. How am I going to implement this? Well, I'm going to say if, now this is STK code, if evaluator of cat_exp, then I want to evaluate this, right? This is the car, the catter, the catator, the cateditor. Right? Otherwise, I want to eval the cateditor, which unfortunately doesn't exist. So I'll say, as a primitive, I mean. So I'll say evaluator of listref exp 0, 1, 2, 3, 4, 5. Okay? So now I've written a piece of code that evaluates something that isn't a scheme expression. In Scheme, you can't say that. If blah, else, then blah, else blah. In Scheme, you have to say if blah, blah, blah. So this code is different from the code up on the screen for eval if because it evaluates a different piece of the expression. Writing schemulator like this feels a little bit less like cheating because I'm using STK's if to evaluate something that is not a scheme if. Okay? It's a little bit more like a Java if. You know, we could even put braces in and, you know, make it more interesting. More like a Java if. Well, if it's not cheating for schemulator, it's not cheating for scheme 1 either. It's really okay to use STK's conditional mechanism as part of the algorithm for implementing scheme 1's conditional mechanism. Okay? Now, what we do have to do is make sure that we use scheme 1 techniques to evaluate each of those pieces when it's time to do so. So that has to be an eval 1 in there and not an STK eval for each of those 3 arguments to the if.